Well, hello folks. It is so nice of you to join me today. And today I'm going to do something, believe it or not, in 20 plus years I have never done. That is hook up a stepper motor to a driver and make the motor work. And that's what we're going to do today. I've got a Arduino Uno. I've got a stepper motor driver and the stepper motor. It's a NEMA 17 stepper motor. I'm going to hook these up today, get you some very simple code. We're going to make this motor spin in one direction and spin backwards in the other direction. There's a bunch of people that have already done it, but it's kind of the hello world program for the stepper motors. Okay, I put the heat sink and I attached it to the chip. There's some sticky stuff on the back of it. You peel off the little cover and just stick it right down on the chip there. Make sure that none of these things are shorted. And this is a A4988 driver. It's really popular. There's a ton of them all over the internet. You can get them very cheap. I got mine from Amazon. I will leave all the descriptions and the links to where you can buy this stuff in the description below. Like I was saying, this is a NEMA 17 motor. It's actually kind of heavy. It's very nicely machined. And I've got your average everyday Arduino Uno. Today we're just going to do a very basic program. All right, here's where we're going to start here, and this is our direction and stepping pin. The stepping pin is going to use to step the motor 1 degree at a time, and the direction pin will be the direction either forward or backward. And from there, we're going to come down here to the setup, and we're just setting them both up as outputs. Then we're coming down here, and we're going to set the direction pin high for 1 rotation. And then we're going to use 200 pulses, and we're going to come in and step it high. Then we're going to use a 1000 microsecond delay and then step it low. Then we're going to use another 1000 millisecond delay. Microsecond delay, pardon me, and do it all over again 200 times. So why 200 times? Well, if this is a 1.8 degree motor, so 1.8 degrees for every step. So if we take 360, which is 1 rotation, and divide by 1.8, we get 200. So we need 200 pulses to move 1 full rotation. Then we're going to come down here. We're going to delay for 1 second. And we're going to do it all over again, only changing the pin direction. So the motor will spin in the opposite direction. And we'll do another 200 pulses. Wait another second and start the whole thing over again. This just goes in one direction, the other direction, endlessly. So let's go ahead and see what this looks like. Okay, let me show you what I've got here. I've got a power supply set to 12 volts. You come over here to the perf board here, a pin cushion. I've got the 12 volts going in there, and that's going to all the little red lines. Those are 12 volts. The blue lines are ground, except I've got the 12 volts disconnected from this line, and I've got that line going to the output of the Arduino, and I've got the 12 volts going into the input of the Arduino. So using the regulator on the Arduino to set up for the logic, or the stepper motor driver. Got a couple capacitor filtering on the power line for this driver, and there's 12 volts going into the driver to drive the stepper motor. So I'm going to turn on this motor here, and I've got this little red thing I've got off. I don't even know what it is. It fits on top of this perfectly so we can see the motor move. I've got the sketch downloaded to the Arduino. Everything is hooked up, ready to go, so I'm going to go ahead and hit the power button on the power supply. And you can see that's going back and forth like it's supposed to. It's going pretty quick at 1000 microseconds delay per step. Here's what I'm going to do. I'm going to go back in and change the time between steps to 3 milliseconds. And we're going to see what that does, how it slows down the stepper motor. Okay, I modified the sketch and I uploaded it to the board, slowed it down considerably. Let's see what it does here now. and it did slow it down. That's kind of cool. This is what you should do with this software. You got to play around with it. Just start commenting out stuff and then uncommenting other stuff, change the times around. Just mess around with it. That's what will give you the confidence to keep on going with this type of stuff. On this chip here, there's some gotchas. You're going to have to make sure that you connect all of the logic to 5 volts. And 12 volts goes on to this pin 16 here on the top right. 1A, 1B, 2A, and 2B go to your motor. And the VDD, which is also 5 volts, goes there, as well as ground. There are these other pins here. This enable pin, which is active low, we're not using that. Also MS1, MS2, and MS3. And what those things do is setting your different steps. Right now it's set for full step, and you use the MS1, MS2, and MS3 to change that from whole step all the way down to 16th steps, which would mean all of these 3 pins would be high. And these are logic pins. Don't connect these things to 12 volts or this chip will fry instantly. Now, of course, I would never do that because I'm a complete professional. But that's something you're going to have to look out for. So what I've done here is I've put a jumper on MS1, 5 volts to MS1, and that's going to change from a full step to a half step, and we'll see what that does to the motor here. And you can see it's changed. Instead of a full rotation, it gives us a half rotation. Now, instead of jumpers here, you can see that if we hook those 3 pins up to our microcontroller, we could actually have a lot of very fine control over this stepper motor. We can control this thing all the way down to 16ths of a step. I'll leave all of the data sheets and everything down in the description so you can read through that. I'm not going to go through all of it here, but what I want to do is have an entire thing. I'm not sure what I'm going to call it yet, but I think I might call it CNC Club. And what I'm going to do is just make a series of this and eventually keep building on one piece at a time so we can slowly kind of learn how this stuff works, because I'm not exactly sure myself. So if you want to learn this stuff with me or at all interested, please give a thumbs up to the video. If this is nothing you're interested in, give thumbs down to the video. You can also leave your comments in the comments below and tell me what you think of this series, if I should keep going with this or not. I'm going to keep going with it regardless of whether you guys want to see it or not, because I need to do this. Eventually I want to build a CNC router of some type. Not exactly sure, but one thing is for sure, after doing this type of thing, you will be much better at understanding CNC stuff. If you do this from the ground up, you will have a big advantage over someone who has never done this before. So stick with me with this series. Thank you so much for watching, and I will see you next time.